Hey guys, welcome to chapter 10. We've only got 2 chapters left in the book, and today we're going to combine lessons 10.1 and 10.2 because they both have to do with graphing and comparing graphs to parent functions. So make sure before you really get into this lesson that you have your cheat sheet along with the notes that I gave you. In this first lesson, lesson 10.1, we're going to look at graphing square root functions. So those are going to be, you can see in the definition, functions that contain a square root with the independent variable in the radicand. And remember, we've learned that the radicand is that piece of information that is underneath the radical. It can be a number, it can be a variable, but that's the radicand. So in these functions, there's going to be a variable under the radical as well as a square root symbol. So the essential question for today, what are some of the characteristics of the graph of a square root function? Now you can see from the picture that I've put into your notes, a square root function has very much a maybe a banana shape again, but really you can see where there's a definite endpoint. The difference between this shape and the one we've seen before with exponential functions is there is a definite endpoint to this graph, and then it's going to go off in one direction. It's going to kind of climb. But as long as you can identify 3 points for me, I'm not going to expect the rest of the graph to be perfect. But you can see from this shape, it's kind of got that banana type shape to it, but it's got a definite endpoint. But before we get into graphing, example 1 wants us to describe the domain of the function. Now we have learned and gone over and over that the domain of any function are those x values. So here's what we're going to do. Very simply, we're going to take the expression under the radical, and we're going to set it greater than or equal to 0. And then we're going to solve for that variable, which is going to be x. So I want you to highlight. If you've got your highlighter, go ahead and highlight that little piece of information. How do you describe the domain? You take the expression under the radical, and you set it greater than or equal to 0, and then you solve. So we look at letter A, and underneath the radical, we have an x. We set it greater than or equal to 0, and we solve, but x is already isolated, so this is our answer. The domain of this function is all the values greater than or equal to 0. If we move on to letter B, remember we're just taking the piece under the radical, so we're going to take 2x and we're going to set it greater than or equal to 0. And of course, to get x by itself, we're going to divide both sides by 2. So x is greater than or equal to 0. Now, lastly, we're going to take what's under the radical in letter C, which is negative x plus 1. We're going to set it greater than or equal to 0, and we're going to solve. Obviously, we're going to move that positive 1 first by subtracting it, and we're going to be left with the negative x is greater than or equal to negative 1. Now, there is an understood 1 in front of this x, and since it's a negative 1, we also have to move it. So we're going to divide both sides by negative 1. And of course, any time the last thing we do is multiply or divide by a negative number when we're dealing with inequalities, we have to flip the sign. So this becomes x is less than or equal to, and of course, negative 1 divided by negative 1 is a positive 1. So this is how we're going to describe the domains of these functions. We're going to take the expression under the radical, set it greater than or equal to 0, and solve for x. Now, an example number 2, they want us to graph the function, and this time they want us to describe the range. So hopefully you remember, and you can go below A and B, and let's go ahead and put range, and let's put our y, because we know our range has to do with our y values. So we're going to be looking at the y values once we have graphed these functions. Now you need to grab your phone, and you need to open to Desmos. Now remember, before you plug this function into Desmos, the g of x, we're going to replace that with a y because that's what Desmos recognizes. So when you're in Desmos, and I'm in Desmos with you, so I'm just going to kind of talk you through this. Obviously, we're going to do y equals, and then when you hit that keyboard button to show the keypad, you can see where the square root comes up. So we're going to do the square root, and then of course under that we're going to put an x. Then we're going to hit an arrow so we can get out from underneath the radical before we put the minus 4, because the minus 4 is not under the radical, it is outside of the radical. And then if you make that, you move that graph around, the very first thing you want to do is find that endpoint. And I find that endpoint right at -4, 0. So we're going to plot that point, and of course we're going to label it 0, 0, -4. Now we need 2 other points, so it's a good idea to kind of spread our points out so we get the graph going in the right direction. I see another point at 4, -2. So I'm going to go right to 4, and I'm going to go over to -2, and I'm going to label that point as well. So 4, -2. And then we need one more point, and if we go too far, we're going to kind of get off of the graph. You can see it crosses the x-axis at 16. So let's try to find one more point that is right on. If you zoom in to where you're seeing every single spot, there's another point at 1, -3. So if we plot 1, -3, and of course we're going to label it 1, -3. Now we want to be careful as we graph this. Remember, we have to start at the 4. Our graph cannot go below that 0, 4. So we're going to graph it, we're going to curve it. We're just going to kind of curve it because we know eventually it's going to cross the x-axis. But you're going to notice that there's only one arrow. Okay, our 0, -4 is our end point, so we want to make sure we don't have an arrow except once. And guys, you know I cannot stand when my graphs don't look good. So let me redo that. So we got our lines, we draw through those 3 points, and then we just kind of go off up into the distance, and we put an arrow only on one end. Now, our graph clearly has a stopping point at -4. So we know that the number in our range is going to be that -4. The question is, are our y values getting bigger than -4 or less than? And hopefully you can see as the graph goes off, it goes up. And so y is going to be greater than or equal to -4. So there's your graph and there's your range. Now go ahead and pause the video and do letter B. Now hopefully this time as you did letter B, you did y equals, and when you put that radical into the problem, x plus 5, that entire thing goes under the radical. Again, if you move your graph around until you find that endpoint, there was an endpoint at -5, 0. So we plot that point and we label it. I also found a point at -4, 1. So we got -4, 1. And this time if you could go off far enough to where you could find a point a little bit higher, there was a point at 4, 3. So if you go right to 4 and up to 3, that kind of helps you take your graph to the height that it needs to go. But again, you should make sure that that graph stops right at that end point. And then of course, there's an arrow only on one end of our graph. Now for this one, our lowest y value, since the end point hits at -5, 0, that lowest y value is 0. And once again, we can see that our graph goes up, so y is greater than or equal to 0. So hopefully graphing these is easy and the domain and the range information is coming back to you. Now the last example in 10.1 asks us to compare the graph to the graph of f of x equals the square root of x. And if you remember from all of our other functions, this is called our parent function, and that might be a great note for you to add if you can't remember. This is called the parent function. That means that we are searching for the square root of x so that we can easily see the changes that have been made to this function. So if you look at letter A, we kept it simple in letter A. The only difference in this problem is this 1/4 that is underneath the radical in front of the x. So hopefully if you grab your cheat sheet, you can see that they are just multiplying x by 1/4. And so that takes us down to the horizontal stretch or shrink. So now we got to decide, is it a stretch or is it a shrink? And so if you look at 1/4 and you plug it into your problems, is 1/4 greater than 1 or is 1/4, does it fall between 0 and 1? And hopefully you can see that 1/4 falls between 0 and 1, which makes this a horizontal stretch. But remember, the stretches get a little bit more complicated because it's a stretch by a factor of 1 divided by a. So a horizontal stretch, and let me finish writing down what I know already. A horizontal stretch by a factor of. And so we've got to take 1 and we've got to divide it by that 1/4 because our A value is that 1/4. Now, if you grab your calculators and you do that on your calculators, 1 divided by 1/4 is going to give us a 4. So our horizontal stretch is by a factor of 4. So make sure you're very, very careful when it's a horizontal stretch or shrink because you can't just use the number that you see. Now, if you move to letter B, again, the parent function is the square root of x. So you can very easily see they have from the f of x function, from the entire function, they have subtracted 6. So if we look at our cheat sheet, when they are subtracting something from a function, that is a vertical translation. Okay, make sure we're using the word translation. We changed that on our cheat sheet, so make sure you're not using the word shift, but you're using the word translation. Now, this is a -6, so this is exactly what we would think. It's a vertical translation down 6 units. So since it's -6, it is shifting down, and it's shifting down 6 units. Now, if you'd like to pause and see if you can figure out letter C on your own, that'd be a great idea. Be very careful when you look at letter C, and remember that the negative sign is a transformation all on its own. Then you've got the 3. So don't get confused and try to figure out a -3 being multiplied by the function. The negative is its own transformation and the 3 is its own transformation. So hopefully, again, if you can identify that this is your parent function, the negative is put in front of the entire function. So this is a reflection, and since it's being done to the entire function, it is a reflection across the x-axis. It is a reflection across the x-axis. Now we got to figure out what we're going to do with that 3. Again, that 3 is being multiplied by the entire function. So when a number is being multiplied by the entire function, that takes us down to vertical stretch or shrink. Now, I put a stretch, but let's see if I'm right. Okay, if the 3 is greater than 1, then it's actually a horizontal stretch. Look at that. I wrote it just without even thinking about it. But it absolutely is. If you're on the vertical, when your A value 3 is greater than 1, it is a vertical stretch. And we like vertical stretches because it's by a factor of the exact number that you see. So this is by a factor of 3. So there are your 2 transformations for letter C. Now, go ahead and pause letter D and work letter D on your own. This one I got real fancy with, all right? You see the parent function here. So you've got that negative sign, you've got that 2, you've got that -3 under the radical, and you've got that -2 outside of the radical. So we actually have 4 transformations on this graph. So let's start and work our way left to right. That negative sign is in front of the entire function. So this is a reflection again across the x-axis. All right, they're multiplying 2 by the entire function. So again, that takes me to vertical stretches or shrinks. And since 2 is greater than 1, that is a vertical stretch. And remember, we like those vertical stretches because it's by a factor of exactly what we see. So a factor of 2. Then we have under the radical. So being done just to x, they have subtracted 3, which takes us to a horizontal translation. A horizontal translation. And be very careful, because when we see -3, we would think left, but remember with horizontals, it's the opposite of what we see. So a horizontal translation, actually right 3 units. And then of course that -2 is outside the radical, so it's being done to the entire function. So that is a vertical translation, and vertical translations are exactly what we see and what we would think. If it's -2, it's a vertical translation down 2 units. And there are your 4 transformations. And I'm hoping that the more we have been practicing with this cheat sheet, the easier it is getting for you to recognize. Now, that takes us into lesson 10.2. In this lesson, we're going to be graphing cube root functions. So you can see from the definition, these are radical functions with an index or a root. We've been calling it a root of 3. So if you look at this picture that I gave you, all right, you can see how there's your radical sign, but it's a cubed root instead of a square root. The essential question, what are some of the characteristics of the graph of a cube root function? And again, you can see this is more of a snake-shaped graph. So you got to be real careful. You've got that point in the middle where the graph approaches and then it curves. So when you're graphing these, you want to make sure you always find that middle point, and then I would get you a point to the left and I would get you a point to the right. Now this is going to be a little bit trickier in Desmos because you got to make sure you understand how to do that cubed root. So let me again talk you through this in Desmos. Remember that both the h of x and the m of x have to be changed to y's before you plug them into Desmos. Once you're in Desmos, you're going to do y equals, and then you're going to go down to that keyboard button again, and you see where it says functions over above the 2 arrows. Hit that function button, and at the very top you see trig, stats, distance, and miscellaneous. Hit that miscellaneous button, and then if you go down the middle column, you're going to see the nth root. See how it's a square root and it's got a little n where the root normally sits? You're going to hit that button, and that's going to allow you to punch in the 3, the root of 3. And then you hit the arrow over and it takes you under the radical, so you can put your x. Hit that arrow again to take you outside from under the radical before you put in your plus 3. Now again, if you move your graph around, you can see that the turning point, and you might have to zoom in so you can get exact points, but you see that that turning point is at 3, 0. So you want to plop that point at 3, 0, and of course we're going to label it, so we've got 3, 0. So we talked about getting a point to the left of that turning point and a point to the right. So if we do that, I see -1, +2. So -1, +2 would be a good point to plot and label. And then a point to the right of the turning point, 1, 4. I mean, let's keep it simple. We've got 1, 4. So we're going to plot and label that point as well. Now you got to be careful because you got to remember the graph is approaching that first point, and then once it hits that center point, it's curving before it goes and hits that second point. And this time we're going to have arrows on both ends. So it approaches that middle point, and then it begins to curve. All right, so just be really careful when you're plotting these points. Now, it asks you to compare it to the parent function. And I'm not going to make you graph the parent function because, again, we can just look at the formula and we can see that they've added a 3. So when they add a 3 to the entire parent function, okay, keeping in mind our parent function is that cubed root of x, we can see that that is a vertical translation up because it's plus 3 units. All right. Now, if you'd like to pause and graph Desmos and then come back. Again, hopefully you put in y equals and then you hit that keyboard button, you hit functions, miscellaneous, and down the middle column to that nth root, punched in the root of 3. Hit that arrow to get you underneath, and this time the x minus 5 all stays under the radical. So again, we're looking for that turning point, and this time we see it at 5, 0. So we're definitely going to plot 5, 0. And again, if we find a point to the left, I see one at 4, -1. So I go right to 4 and down to -1, and I label that point. And then I want one to the right. I see one at 6, 1. So I go right to 6, up to 1, and we'll just keep it real simple. But we got to be careful because remember our graph approaches that middle point and then it turns. Okay, and I know we're going right over that number we labeled, but put that arrow on the end. So just be very careful and make sure you get that curved point, that turning point in the center. Now, if we look at the equation, the -5 is underneath the radical with the x, so we know that is a horizontal or we should know by now, that's a horizontal translation because they are just subtracting 5 from the x. But remember, we think left, it's actually right, 5 units. So I'm not going to make you graph the parent function. I just want you to graph the new function and then figure out the transformations from the equation. Now that takes us into our final example, where we are once again asked to compare the graph to the graph of f of x equals the cubed root of x. So remember, this is our parent function. Right? Again, not a bad idea to make that note if you need to remember. Because remember, in order for us to find the transformations, we've got to be able to recognize the parent function. So if you look at letter A, you can see the parent function right here, and you can see that underneath the radical, there is a 0.5 being multiplied by just the x. So again, when something's being multiplied by just x, that takes us down to the horizontal stretch or shrink. So we got to plug that 0.5 into those equations. Is 0.5 greater than 1, or does it fall between 0 and 1? And hopefully you recognize 0.5 as a half and recognize that it does fall between 0 and 1. So this is a horizontal stretch. But again, we've got to be careful because it's not by a factor of what we see. We actually have to do a little bit of math. You have to take 1 and divide it by that a value, which in this case is 0.5. So when you do 1 divided by 0.5, you're going to get 2. So the horizontal stretch is by a factor of 2. You also see that they've added 5 outside of the radical, so to the entire function, which means we have a vertical translation. And I just know you guys are getting so good at these now. Horizontal translation. Again, exactly what we see. It's a positive 5, so up 5 units. So this one had 2 transformations. We're going to box them in. Now, pause and do letter B on your own and then come back and see if you got it right. You've got a 4. If you find the parent function, you can easily see the 4 being multiplied by the entire function and the minus 1 being subtracted from just the x. So we'll start with the 4. I like to work left to right. This is a vertical either stretch or shrink because they're multiplying the entire function. And since 4 falls into the greater than 1 category, this is a vertical stretch. And remember, verticals are by a factor of what we see. So by a factor of 4, there's your first transformation. And then of course, when they are subtracting 1 from just x, that's a horizontal translation. A horizontal translation. And again, it's horizontal, so it's the opposite. We see minus 1, we think left, but it's actually right, 1 unit. So there are your 2 transformations for letter B. Letter C, same thing. Pause, see what you can figure out on letter C, and then come back. On this one again, I saved the more complicated one for the end. Here's our parent function. So the minus is a transformation all on its own. We've got the 1/2, we've got the plus 2 with just the x, and the minus 4 back outside of the radical. So the negative has been done to the entire function, which makes this a reflection across the x-axis. You've got the 1/2 being multiplied by the entire function, so we know that's a vertical. Now that 1/2 falls between 0 and 1. So this time it's a vertical shrink, again, by the factor of what we see. So by a factor of 1/2. Then you've got the plus 2 being done to just the x, so we know it's horizontal. It's a horizontal translation. Now be careful, this time it's a plus 2, so we think to the right, but it's actually to the left 2 units. And lastly, we've got that minus 4 being subtracted from the entire function, so we have the vertical translation, and this is going to be down because it's negative 4 units. So again, I think it's imperative if you can find the parent function, I think seeing the transformations is going to be even easier for you. Now, I've got one more thing for you to do. I actually want you to go back to example 1 in this lesson, this 10.2 lesson. Go back to example 1, and I want you to do 2 things for me. First of all, just to help you a little bit on Desmos, just kind of write in the pattern to how you plug this in. All right? So in order to get that cubed root, you're going to hit the function button, then you're going to hit the miscellaneous button, and then you're going to hit that nth root button. All right, so add that to your notes because I think that'll be helpful as you're studying for your next quiz and your next test to remember. It might not naturally stay in your memory. So it's going to be the function button, then the miscellaneous button, and then that nth root button. That's what's going to allow you to put that cubed root into Desmos. All right, and even if you want to write Desmos as your first word, to remind you that's where you're going to use function, miscellaneous, and the nth root, okay? And then, just so I know you watch this to the bitter end, I want you to tell me next to example 1 who your very best friend is. I hope you guys have an awesome weekend, and I will see you on Monday. That's lesson 10.1 and 10.2.